For us to figure out what angle theta is, so we have what's opposite of theta, and we have the hypotenuse. And since whenever we make an equation, we only want one thing we don't know, or else we can't solve. The thing we don't know is the angle this time. So this equation lends itself to sine because we have the opposite and we have the hypotenuse. Sine is the opposite divided by hypotenuse, right? So we got sine of theta is going to equal the opposite divided by the hypotenuse. Okay, just use our definition of sine. I plugged in sine of theta equals 7 over 10. Because 7 is opposite of theta, 10 is hypotenuse of the triangle. And now we can get theta by itself. I need to use something called inverse sine. So if you, here I'll do it in red. I'm doing something to both sides of the equation. That keeps it balanced, and we use that negative 1 up top for the notation of inverse sine. But I have to do it at both sides, or else it's not balanced. Okay. So I did that to both sides of the equation to get theta by itself. Now over here, sine of negative 1 of 7 over 10, we need our calculator for that part. Okay, just watch out, depending on the situation, whether you want it to be in degrees or radians. So we'll just assume radians. You would get a slightly different answer if you had degrees. But 7 divided by 10, oops, going to hit equals. And then in the Windows calculator, you hit trigonometry, and then you need to hit the second key. And there it is. That's the inverse sine we're looking for. So 0.775 roughly. So that's in radians, 0.775. That's the angle measurement. But if you wanted that in degrees, remember, well, I guess it's harder when you don't have a pi. So you could just go back and switch your calculator. That's 7 divided by 10. Oh, I'm hitting all the wrong keys. 7 divided by 10 second. Oh, I'm still in radians. Degrees, so I'm going to hit second sine. So there we go, 44.4 degrees.